Everyone. Today I'm going to explain one of the most frequently asked question in Amazon interviews, which is called as longest palindromic substring. Let me read out the problem statement. Given a string S, return the longest palindromic substring in S. If you don't know what is palindrome is, if you see the output here, BAB for the example 1, if you reverse the string or if you read it from start, it looks same. Basically, it's like a mirror image from center. And if you see the second output second example's output, BB is a mirror image to each character. But this is even length and that is odd length. I'll come back to those later. If you see the constraints, the length of string is going to be 1 to 1000. That means order of n square should be they're expecting us to make it at least with the time complexity of order of n square. So yeah, if it is around 10 power 7, we should be able to come up with the 10 power order of n solution. I mean order of n time complexity. And S contains of only digits and English letters. Let's try to go through this now. Here you go. We can solve this problem in two approaches. First one is now the brute force, and then we can use expand from center approach. This will take order of n cube, and this is going to take order of n square, so order of n square time complexity. Let me explain the brute force first. So for brute force, what we can do is we can find out all the substrings like B. For the example, S equal to B A B A D. We can take all the substrings like B, BA, BAB, BA, BAB, BB, BAD, yeah, and then AB, AAA, something like this. That means it is first we will get order of n square strings, substrings, and then for each substring we'll check whether the substring is palindrome or not, which is like n um, time complexity, order of n time complexity, because we have to put two pointers at start and one pointer at start and one pointer at end and compare each other. So this is going to be the order of n for order of n square for n square substrings. It is going to be order of n square into n, which is nothing but order of n cube time complexity, which is too much of um, um, the time complexity, which is very slow, and if the string is very large, the CPU will time out. Now let's go with the second approach, which is expand from middle or expand from center. So for this, what we're going to do is, for the example BABAD, we'll first try to expand from the same index, let's say I. We'll try to go in this direction first, then this direction, and compare whether the characters are same or not. If not, we will increment the I and go to the next character, right? Um, but after that, after expanding from same position, we will also expand from side by side or adjacent indexes as well. The reason why we are doing this is because I will explain now. So the substrings that were given can be even length or odd length. Let's say for the first example, it's how many characters it has? One, two, three, four, five. It is odd. For odd length, let's say I'll take one more example, BAB, which is odd length. If you expand from middle character, first we will check AA. So we will initialize I comma j as from the same position. AA will match. Now, if you expand I to I plus 1, maybe we can reduce the I to I minus 1. That means it will come here. And j will increment to plus 1, will come here. And now we'll check b equal to b, and it matches. At the same time, we are also making sure we are tracking the length. So this is how odd length character is, which is 3. For even length, let's say CBBD, which is the other example that was given. Now, if we expand from, let's say, from the same position, we might not be able to find out this pair, which is palindrome here. CBBD. Let's see how that is going to happen. I comma I comes here, J goes here, which will fail because I is less than 0, which is one of our one of our edge case. Now we will in the next pass we will update will put I at this I comma j at this position. Now I goes to C. Yeah, I goes to C, and then J goes to B, which is not matching, and this pass will fail. Now we will increment I comma J to the third index, and now we will decrement I to B, and now J goes to this D position, which are not matching each other, and hence we will be never be able to find out the palindrome, which is BB, because of because we are starting at the same position. Instead of that, let's say if we start at adjacent indexes like this, we will go to B comma B at one point, and we will compare those characters and find out that they are equal, and our max length of palindrome is going to be 2, and we will return that. So that's how for this problem, first we have to check the odd length approach as well as even length approach, right? I'll show the code, but time complexity is going to be order of n square, because for every character we are expanding and comparing. Let's say if we expand from one position, we will compare. Um, we will read all the other characters as well while when we are expanding, and this is happening for each character, right? And that is nothing but n into, let's say, n expansions and comparisons. n comparisons, n expansions into n comparisons equal to order of n square is the time complexity for this problem. I will write the code now. Let's declare one function called as longest palindromic substring, which will accept string. Let's first create empty string as a result for I in range of length of s. We will, as I told, we will iterate, we will expand from each position, right? So first we will do the expansion for odd length. P1 equal to, let's say there is a function called as expand I comma I. For P2 means we will expand side adjacent characters I comma I plus 1. If length of P1 greater than length of result, we'll update result to P1. Let's say if length of P2 is greater than length of result, we will update result to P2. And at last, we will return result. Let me write the code for expand now. This is going to accept the positions. Basically, we can call it as left comma right. So this is nothing but making sure that edge conditions are the left and right are, first we have to make sure the left and right are not uh, left should not go beyond 0 and right should not go above the length of the index. So that means while left greater than 0, or it should be greater than or equal to 0. Yeah, greater than or equal to 0, and right is less than length of s. It should accept a string as well, right? And one more edge condition should be, as long as the left and right are equal, we should keep on expanding. We'll decrement by 1, increment by 1 the right pointer. Return s left plus 1 to r. That's it. This is a expand method. Time complexity is order of n square, which I have already explained above. That's it, guys, today. See you in the next video.